Hello, I'm Zach with Chegg Tutors, and today we're going to talk about special triangles. Special triangles are a thing that everyone learns, and then sometimes people forget them, and that's okay, but they help your life out a lot, and they're important to remember. So this one over here, this is a 30 by 60 by 90 degree triangle, and this one right here is a 45 by 45 by 90 degree triangle. And those degrees are giving us the angles, right? So this one right here is 90, this one here is 60, this one here is 30, right? This one over here, 45, this is 45, this is 90. We can also talk about these angles in terms of radians, of course. 30 degrees is pi over 6, 60 degrees is pi over 3, and 90 degrees is pi over 2. It's more common to hear 30, 60, 90 degree triangle than to hear pi over 6, pi over 3, pi over 2 degree triangle. But you could talk about it that way if you wanted to. And over here we have a pi over 4, pi over 4, pi over 2 degree triangle. If you're, for example, using the sum and difference formula to find the exact value of trigonometric functions, one thing you want to do is break the angles that show up down into angles where the trig values are easily known, are known exactly. And that's one thing that special triangles do for us. So we know, it's a fact, that we have two examples of these triangles. This is an example of a 30 by 60 by 90, and that means that if you cut a stick of length 2, of length 1, and of length square root 3, and you put them together, the result will be a 30, 60, 90 degree triangle. And over here, well, there's a number of different ways of writing this, but we'll stick with this one. So if you cut a stick to a length of square root 2 and 2 sticks of length 1 and you try to put them together, you will get this shape. You will get this right triangle. And so these two things together allow us to, and so what we can do is we can use these two triangles to figure out the trigonometric values of various angles. For example, the cosine of 60. And so the question is, what is that? Well, here's 60 degrees down here. It's opposite this larger angle, square root of 3, which is larger than this one. And cosine is adjacent over hypotenuse. In this case, it would be 1/2. Exactly 1/2. All right, no funny long decimals that we're truncating or approximating or rounding up. None of that. What about sine of 60 degrees? Well, sine of 60 degrees is the square root of 3 over 2. Because sine means opposite over hypotenuse. Right? Let's do a couple more. Once you get used to them, they're pretty straightforward. The trick is to memorize them and to get comfortable with them. So what about sine of 45? That's this cosine of 45. That's 1 adjacent divided by the hypotenuse, 1 over square root 2. Sometimes you'll see this rationalized, and what that means is that they multiply the top and the bottom by square root 2 to get square root 2 divided by 2. These are the same fraction, even though they look different. And there's no real advantage to one over the other anymore, I don't think. Some people like to rationalize their denominator. Rationalizing the denominator is a nice tactic that comes up later on in solving some things, so it's not bad to practice, but I don't have a preference between one and the other. Sine of 45. Well, that's also 1 over the square root of 2. Okay? So, that's all well and good. What if I wanted to figure out cosine of 75 degrees? And I wanted to figure it out exactly. Well, what I could do is split that 75 into 45 and 30. Alright, there's a sum rule for cosines. And I'm going to look it up real quick so I don't mess it up. Okay. So what we have here, we're going to have cosine 45 degrees by cosine of 30 degrees minus sine of 45 degrees sine of 30 degrees. Now we can find each of these exactly because these are all angles from special triangles. So cosine of 45 degrees, that's 1 over the square root of 2. Cosine of 30 degrees, that's going to be the square root of 3 over 2. Sine of 45 degrees, 1 over the square root of 2 again. Sine of 30 degrees, that's going to be 1/2. Alright, so we multiply these together and multiply these fractions together and combine them into one large fraction, and you get the square root of 3 minus 1 over the square root of 2 times 2. And this is the exact value of cosine of 75. So we see, knowing these special triangles here can actually tell us how to find out the exact values of a lot of other angles. So this is one reason why they're useful. Alright, that's it.